This will be our first video on programming for the web. This video will serve two purposes. We'll be tracing a TCP connection, as well as introducing socket programming. So the problem that we have over here is we want to diagram a connection, a TCP connection. And in this connection, B initiates a TCP connection to A. So we have two entities, A and B. And when you are building TCP applications, in the code, you do need to sort of acknowledge that one is going to be the initiator of the connection and the other will be the one waiting for the connection. These are typically referred to as the server and the client. So in this case, A is the server because it's waiting for a connection, and B is the client. The entity who initiates a TCP connection with someone who's waiting is going to be your client. Okay. So in the lecture that you should have read before looking at this, you know that in order to initiate a TCP connection, you need to do a three-way handshake. Okay, so we'll diagram that. Once the connection is established, B sends 3 segments to A. Okay, so B sends 3 data segments to A. And we can assume that A's window size allows for the acceptance of all 3 frames at once. Okay, so if it wasn't 3, it was like, let's say 3,000 or something, then maybe B couldn't send all those segments at once. It will be able to say something like, I'll send the first 1,500, and then when I get acknowledgements, I can send the rest. But for very small numbers, we can just assume that the window size allows for the acceptance of all the frames at once, all the segments at once. The segments are length 100, 200, and 300 bytes in that order. Okay, so the 3 segments that we're receiving are of length. The first one is 100 bytes, second one is 200 bytes, and the third one is 300 bytes. Okay, A is the receiver. Once A has received all 3 segments, it will send 3 segments to B. Okay, so only after it's received all 3 segments, there has to be some type of collection of the segments over here. Once it's received all 3 segments, it will send its own 3 segments to B. Okay, and again, we assume that B's window size accepts all the segments at once. These segments are of length 300, 200, and 100 in that order. Okay. And then finally, A begins a termination handshake. Okay, so that involves the 4-way closing handshake. And so before we go into sort of drawing the sequence diagrams for seeing how this occurs, I want to show you that I want to prove to you that this is what actually does happen. It's not just sort of theory that doesn't get applied. Okay, so in order to sort of show you this is exactly what occurs, I wrote a program that does exactly that. Okay, so this program, we have 2 entities, A and B. Okay, and B is the entity that initiates a connection with A. Okay, so this is what line 4 does. Line 4 initiates a connection on port 35,555. And before this occurs, I would start in my A program, would set up a server that listens for connections on 35,555. Okay. So this code is, before we go a bit further, it's reliant very heavily on the observer pattern. So make sure that you are sound with that topic before I go further. Okay, so essentially when I do server.listens is it sets up a listener on this port, and what's going to occur when that listener fires. Okay, so if I get a new connection, this function over here, this function connection, which I've attached to the server, fires. It fires every time I get a new connection. So if I open up multiple instances of B, this will fire multiple times. Okay. So what happens when it gets a connection? Well, when a connection is received, it sets up two listeners. Okay, it sets up two listeners, one to listen for data, and one to listen for a fin. Okay, so this is listening for a four-way closing handshake initiation. But notice it doesn't do anything. It doesn't send anything. It just sets up two listeners. It says that, okay, if I get a connection, there's going to be a socket, and then I'm going to listen for data, and I'm going to listen for a end signal. And that's because A is not the entity that starts sending data. Okay, if we go back to the problem, it says, once the connection is established, B sends 3 segments to A. So B is going to be the one that's sending data. So that's why over here, when I create the connection, there is only 2 listeners. I don't have anything like socket.write immediately. And if you wanted A to send data, then you would put something like socket.write over here if you wanted A to start transmitting data. So it's not saying that A won't transmit data. A does transmit data later on. Over here we can see that there's a socket write function that calls socket.write over here. But it's not doing it when a connection is established. Okay, so let's look at B. So when B connects, okay, it also has a connect function. Okay, and that connect function also has two event listeners. Okay, the keyword this is referring to the socket in this case because the connection is the socket. Okay, and so it has two event listeners, one listening for a fin and the other one listening for data. But then we have this socket.write. And what this function does is it's going to write 3 segments. It's going to write 3 segments to A. And I want this to occur synchronously. Okay, I want 100 to be sent, then 200 to be sent, then 300 to be sent. And if you recall from previous lectures, in order to do something synchronously, I'm going to have to do it recursively. Okay, so over here you can sort of see that I have a recursive function, socket writes, which is going to call itself. Okay, so over here, first I check to see if the array that I'm setting in is empty, and if so, then that's my base case. Okay, if there's nothing left to write, then I'm done. Okay, otherwise I'm going to pop off the frontmost elements, so 100. Okay, so I'm going to be writing 100 bytes, and this function over here, crypto.randomBytes, is just generating some 100 random bytes. Okay, so I'm going to use socket.write to push that onto the socket towards A, and then when the writing is finished, there's a callback over here. The callback over here is a bit messy. It's going to set a timeout that after 1 second, it's going to call recursively socket.write. And this set timeout is not important. I only kept it here so that you can see the delay. So you can see that it's sending 100, then wait 1 second, then send 200, then send 300. You can definitely remove this set timeouts if it's not helping and causing confusion with your code. It'll just run much faster. It won't have that built-in delay. Okay, but it's not important to the functionality of this code. Okay, so it's going to send. So essentially, what this B file is, as soon as it connects, as soon as it finishes the 3-way handshake, it's going to send 100, 200, and 300, and that's going to be caught by the data handler on A. Okay, so that's going to be data. So because I set up an observer for the data event, each time it gets data, it's going to increase the number of segments by 1. Okay, it's going to print out received data.length bytes. And then if the segments matches 3, okay, so you can see that I'm collecting the segments over here. Actually, I don't care about the data, so I'm just throwing that out. But I care about the number of segments that I've received. If the segments reaches 3, then I'm going to start writing myself. And this is the same socket.write function. Okay, so it's going to write back and then that's going to get caught by this data handler. Okay, so you can see we're sort of bouncing around back and forth between A and B. So this handler, what does it do? It does the same thing. We have the segments, which is initially 0. It's going to increase it, and then it's going to print out, let's see, right, it's going to print out the length. Okay, but notice that over here we don't. In fact, the segments receive this isn't even important over here, because even if we count to 3, we're not doing anything. Now, it would be useful if B was the entity that decides to close the connection. If B were the one to close the connection, then I might want to do something like segments. If segments received equals 3, then socket.end. Okay, if I receive 3 segments, then send a message to A to say that I want to terminate the connection. But it looks like, if I go back to the problem, finally, A begins a termination handshake. It's not B who initiates this termination handshake. Okay, so it's not B who initiates this termination handshake, so it's A that initiates this termination handshake. Okay, so in fact, if we go to socket.write, where do I add the code into here? So over here, I have the code. Okay, so it's going to write 100, 200, and 300. And then if this array is empty, if the length of this array is empty, then it's going to send a fin. This is probably not the cleanest code. Ideally, there should be some type of callback inside of here that I can pass into socket.write, so that I can sort of make it less messy, because this is doing sort of 2 jobs. It's writing to the socket, it's also closing it. So a bit messy on my part. I would not have this code inside of here, but it works. Okay, so if the bytes array is empty, which means that I've written all 3, then I'm going to send the fin. Okay, so I'm going to run socket.end, and that way A closes the connection after it's sent the 3 segments. Okay, so again, because this is sort of a recursive definition, it's going to send, in this case, 300, 200, and 100. In fact, I should fix this. This should be, A should be sending, once A has sent, it will send B 3 segments, 300, 200, and 100. So let's fix this. 300, 200, 100. Okay, all right. So once these 3 segments are sent, then A will, because this is our base case, and our array shrinks every time the base case happens last. Okay, this will call socket.end after finishing all the other segments. Once B receives a end request, then it is going to, so the end request is a 4-way handshake. So A sends a fin, and then B is going to, the operating system will automatically send back an ACK for that first fin. But then B, inside of here, you can start doing your cleanup code. Okay, so maybe you have to close a database connection. Maybe you have to do some garbage collection or something. Okay, if you have to do that additional work inside of here, when you get the end request, this is when you do it. So in this case, I'm simulating that work over here by waiting 1 second. And then after all that work is completed, it's going to call the function sending fin and this.end. Okay, so this is the 3rd portion of the 4-way handshake. That will send a fin to A, and then A's operating system will automatically send a fin back. I would say A's operating system will automatically send an ACK back, and that will close the connection. Okay, so let's run this. And when we're running this, I'm going to show you a new application which is going to be part of your next assessments. So this tool over here is called Wireshark. It is a network inspector. It's used to inspect packets that are traveling over your network. And the one that we're going to be using, so Ethernet in this case represents my wired connection. If you're using a system with a Wi-Fi module, you might see something like wireless card or wireless adapter. And the one that we're going to be using right now is called the adapter for loopback traffic. And that's because both of these programs are running on the same machine. Okay. In one of the videos that I've recorded, there is a example where I use a different machine, but it's just much more convenient to use the same machine to run them. Okay, so essentially it's just tracking data flowing from my machine back to my machine. Okay, there are some drawbacks. There's almost no latency, and the program runs way too fast sometimes. But it's good enough for most applications to learn about how this works. Okay, so when you're using this, if you just double click this section, it'll track all the data flowing between you and your computer, and there's all sorts of stuff inside of here. Okay, so this red box will allow you to stop capturing packets. Okay, so even just from myself to myself, there's background processes on my computer that will have data inside of it, and you can inspect each of these frames. You can go on the application layer, the transport layer, the network layer, and so on. Okay, you can even look as low as data link layer to look at the frame details. So I'm going to click this X button to close this capture file, and I don't want it, so I'm going to continue without saving. And so there's too much sort of garbage traffic, so I need to filter it out. And Wireshark is a bit finicky with how you filter, so you have to do it in a very specific order. Okay, so you can't start typing your filter into the capture filter right away. It's not going to work. First, you have to choose the connection that you want to listen on. Okay, so I'm going to first choose the adapter for loopback traffic. That's the one I want to listen on. And then you go to filter. Okay, if you don't have this one selected first, then it's not going to remember your information. Now, there's a bunch of ways to filter traffic. In this example, the best way to do it would be to filter on the port. The port number that we're using for this is 35,555. Okay, so it's just port 35555. Okay, and that essentially will ignore all other traffic except for ones occurring on port 35,555. And then once you have that, you can double click this connection again, and now all the previous sort of garbage traffic that occurs is not included in this results. Okay, and so we're going to run this code, and we'll look at to see what appears on Wireshark as it's running. Okay, so A is server bound. Okay, so that refers to this line over here, which means that A is now listening for connections. Okay, so B is sending 100 bytes, 200 bytes, and 300 bytes. A receives those, and then it starts sending back 300, 200, 100, and it receives 300, 200, and 100. And then A is the one that's going to be sending the termination requests. B receives the termination requests, it waits 1 second, then it sends its own termination requests, which A receives, and then the program is finished. So we're going to look at the actual exchange and just show you that this is actually what happened inside of here. So the port that A was listening on is port 35,555. So in this case, we can see the operating system automatically gave us an ephemeral port of 53,182. Okay. And this may change on your system. Okay, it's whatever is available. And so machine B is going to be recognized as, right, our source and destination IP are just the same. So this is not going to be useful to us. So we will identify our two applications by their port numbers. In this case, 53,182 will be B, and A will be 35,555. Okay, so B initiates the handshake, the three-way handshake. Okay, so sends the synchronization request, then we get the synac back, and then we get the ACK. Okay, so this is B sending to A responding back, and then B sending out again. In fact, let me close this. After that, we start sending data. Okay, and it's B sending to A. Okay, it's going to send, in this case, 100 bytes of data. And because I'm working on this is one of the drawbacks. Because I'm working on the exact same machine that I'm testing on, there's no latency. We get a response back immediately. Okay, so normally the order of this response time would not be this fast. Okay, normally I would start sending out the next segments. Okay, meaning that segment 4, segment 6, and segment 8 should be going sort of out at the same time. But because I'm working locally, I get my acknowledgements back almost instantly. Okay, but it's fine. So I'm sending out a segment, I get acknowledgement for it. I'm sending out a segment, I get acknowledgement for it. I'm sending out a segment, I get acknowledgement for it. These are all from B to A, and then the acknowledgement is from A to B. Okay, so once those three segments have been received, our application then switches gears. Then A is going to be sending data. Okay, so A sends to B, sends 300 bytes. Those 300 bytes are acknowledged. Then A sends to B 200 bytes. Those 200 bytes are acknowledged. Then A sends to B 100 bytes. Those 100 bytes are acknowledged. Finally, the connection is then closed by A. So A initiates the closing connection. It sends the first fin. That fin is acknowledged. And then 1 second later, in fact, 1 second later, B initiates a fin to finalize the connection, and A acknowledges that closing. Okay, so what we're going to look at now is how to diagram this. Okay, so it's really easy to diagram when you have the Wireshark outputs in front of you, but most likely, most of the time, you will not have it in front of you. So you still need to understand how to diagram this this setup, just because in most cases you won't have this code that runs it for you. You just have to, you're only given the description. Okay, so I'll leave that over here. Let me shrink it down a bit. Okay, so I'm going to need 3 columns from my previous testing. And so essentially this will continue up here and so on. Okay, and I'll move this out of the way. Okay, so the problem over here says that B initiates in fact, let's shrink it down a bit more so I can read it. Okay, so B, so this will be A, and this will be B, A, B, A, B. All right, so B initiates a TCP connection to A. Okay, so this is probably the easy part. There's a synchronization request. A will acknowledge that with a synchronization acknowledgement of its own. and then B will acknowledge it. At this point, we've reached a socket state that's called is connection established. Okay, connection established. Okay, and when this event happens, it triggers the code, the connection code. Okay, so anything that's listening for a connection event. In fact, I don't have connection events on here, but there is a connection event for the server. You can have something like server.onConnect, server.on. I think it's connect or connection, one of those two. And I think it's probably connection. And then you can attach it to this function. But over here, if you do create server, you can automatically attach a connection like that as well, which is what we do over here. But this connection function is this connection event triggers. And so once the connection is established, B sends 3 segments to A. Okay, and the sizes are 100, 200, and 300 bytes. So in the normal application, so inside of our code, we get acknowledgements back right away, but in most normal applications, that will not happen. Instead, these 3 segments are sent at the same time almost, maybe a delay of a few milliseconds or microseconds. Okay, because we are not exhausted A's window size. A's window size is actually much larger than 100 bytes, a couple hundred bytes. Typically, we could send tens of thousands of bytes easily. Okay, so something like 100 or 200 bytes is not going to be a big deal. All right, so inside these packets, we're going to have sequence acknowledgements numbers. And the sequence number, number allows us to order our segments. And the acknowledgement number ensures that the other party, acknowledgement number represents all the packets that the other party has already received. Okay, so the sequence number and acknowledgement number on both sides starts at 1. So sequence 1, acknowledgement 1, sequence 1, acknowledgement 1. Okay, so since B is sending 3 segments, the first segment is going to have sequence number 1, acknowledgement number 1, and the data in this case is going to be 100 bytes. Okay. The calculation of sequence number is going to be data plus previous sequence number. So the next sequence number, in this case, is going to be 101. The acknowledgement number represents the number of the acknowledgement number represents the next. This acknowledgement number represents the number of segments. This acknowledgement number represents the number of bytes that I've received from A. And so A's acknowledgement number is going to be different than B's acknowledgement numbers. B's acknowledgement number reflects the number of bytes that I've successfully received an order from A. And A's acknowledgement number will represent the number of bytes that I've successfully received from B. So in this case, because I haven't received anything except for this first segment from A, my acknowledgement number stays at 1. And the data in this case is 200. Finally, the third element, the third sequence number in this case, is data plus sequence number. So that is going to be 301. The third acknowledgement number is also going to be 1. Again, I have not received any data back from from A. And the data in this case is going to be 300. Okay, so as A gets these messages, it's going to automatically send responses back. Okay, so it's going to send responses back starting from here, here, and here. Okay, one for this packet, one for this packet, one for this segment, one for this segment, and one for the third segment. And so these segments, they could be sent right away, but because I don't really have room over here, I'm going to say that they arrive later. Okay. And so the sequence number of this, okay, because this is a acknowledgement packet. Okay, so the previous ones, these are just data packets. Data packets don't have special flags attached to it. This is an acknowledgement packet. Okay, so it has the ACK bit set to be 1. Okay, but it doesn't have data inside of it. And because it doesn't have data inside of it, it's not counted for sequence numbers. So the sequence number in this case is 1. The acknowledgement number, so this is happening over here. So it's acknowledging that I've received this segment. And so what the acknowledgement, another way to think about the acknowledgement number is to think about it as the next sequence number that I'm expecting. So the next sequence number that I'm expecting is 101 at this point. Okay, and again, there's no data in this segment, so it's not going to affect the acknowledgement number on the other part. Okay. So next we have this one. Which is also sequence number 1. Okay. And the acknowledgement number, in this case, it is acknowledging the receipt of this segment. Okay. And so 200 plus 100, 101, the next acknowledgement number that I'm expecting is 301. Okay, and finally we have this one, which we will move on to the next line for. Okay, and again, this one is an acknowledgement packet. So it will have sequence number 1, and its acknowledgement number is the next expected sequence number. Okay, so after receiving this, the next sequence number would be 301 plus 300, or 601. Okay, so once A receives those 3 segments, then we switch gears and A starts sending data. Okay. So in fact, at this point, A's sequence number is 1, and its acknowledgement number is 601. And B's sequence number, in fact, let's move it down here after we've received it. A's sequence number, next sequence number that's going to use, because I've sent these 3 packets already, the next one that I'm going to use is going to be 601. But I haven't received any data. I've received segments, but I haven't received data from A. So its acknowledgement number is still 1. Okay, but this is going to change now that A is sending data back. So A is going to send 3 segments. And again, we assume that the window size is large enough to send all 3 at once. Okay, so the sequence number in this case is going to be 1, okay, because this is the first packet that A is sending. Its acknowledgement number is 601, okay, because that's the one that we're at right over here. And the data, so this is also signaling that that A has received everything from B up until 601. Okay, the data in this case is 300. Okay, because we're going backwards this time. The second one, the sequence number is 301. Okay, 300 plus 1. The acknowledgement number is 601 again. And the data is 200. And then finally we have the sequence number of, let's see, 300 plus 200, so that will be 501. Acknowledgement of 601. And data of 100. And again, these three are going to get acknowledged. Here, here, and here. Okay, so the first acknowledgement is the acknowledgement of receipt of this packet. So because this is an acknowledgement, we don't have the data field. We only have sequence number and acknowledgement number. Okay. So when this receives, so our original sequence number acknowledgement is 601 and 1. So our sequence number stays the same at 601. And our acknowledgement number, because we received 300 packets, we are saying that we have received, B has received 300 bytes from A. And then we're expecting the next sequence number to be 301. Okay. Next, after receiving this segment over here, our sequence number is going to be, again, 601 because this is acknowledgement. Our acknowledgement number will be 301 plus the 200 bytes of data, or 501. And then finally, we have the last sequence number, which is 601 and 501 plus 100 bytes, acknowledgement of 601. Okay, so with that, all our data is finished sending. Okay, and once we received all the data, then A begins a termination handshake. So again, the termination handshake looks like this. A sends a fin. Okay. B automatically, as soon as it receives it, it sends back an ACK. Okay. And then over here, we begin working. So this is the shutdown stage, where it is closing up, cleaning up any additional work it has to do. Okay, and once all that is finished, we send a fin back. Okay, and then that fin gets acknowledged. Okay, and so this is a standard connection. Okay, next we'll look at a connection where we have data loss.